of negative feedback amplifier. You know, amplifier is represented by forward triangle symbol marked inside with A. And this amplifier has got fed with the input signal V in, and the output is amplified version of the V in, that is V0. So what amplification is, it is going to increase the amplitude of V in by many folds. For example, if V in is equal to 1 millivolt, V0 would be 10 millivolt. So for this we refer it as amplification. And this basic amplifier is going to have good stability if output voltage is fed back to the input, and the output voltage is fed back through the feedback network denoted by this. This feedback network has got a feedback parameter of beta. Beta is feedback parameter, and what this feedback parameter is going to do is, it is going to reduce the output voltage by beta times. So Vf is equal to, it is the output of the feedback network, Vf is equal to beta times the input voltage V0. V0 is the input to this feedback network. So beta times V0 is equal to Vf. And when fed back the feedback voltage Vf, if it is in phase with V in, we call it as positive feedback, then the effective voltage, final input voltage is V in plus Vf, if it is positive feedback. But if the Vf is out of phase with V in, then we call it as negative feedback. In that case, the final effective input voltage to the amplifier is the subtraction of V in and Vf. Vi is equal to V in minus Vf. So after that we shall proceed to derive the gain of negative feedback amplifier. So for that we are going to write two equations. One is the gain denoted by A. It is the gain of this ordinary basic amplifier with no feedback loop considered. So in that case, only when this much portion is considered, A is equal to output voltage by input voltage. A is equal to V0 divided by Vi. And if whole of the thing, overall amplifier is considered, the gain is with feedback, with all this being considered. So in that case, output voltage is V0 and input voltage is V in. And the ratio of V0 divided by V in is referred as AF, that is the gain with feedback. Gain with feedback is also referred as overall gain or closed loop gain. So we do have two equations, A equal to V0 by Vi, V0 divided by Vi, A equal to, or AF is equal to V0 divided by V in. AF is equal to V0 divided by V in. To have the derivation, finally we intend to derive the AF, that is the gain with feedback, in terms of gain without feedback. So what is the equation you are seeing over here? We want to derive AF equal to A divided by 1 plus A beta, means gain with feedback is equal to gain without feedback reduced by the factor of 1 plus A beta. So if we need to derive this, we are going to get started from this equation, A equal to V0 divided by Vi. A equal to V0 divided by Vi. Then write for V0. Vi goes this side, we are going to have V0 equal to A times Vi. But what is Vi? This Vi is the subtraction between this and this one, because we are going to have negative feedback. So Vi is equal to V in minus Vf. So Vi is equal to V in minus Vf is substituted in place of Vi. So what is that we are going to get? V0 is equal to A times Vi is V in minus Vf, V in minus Vf. Then you open this bracket, A V in minus A Vf is the thing. But we know that Vf is equal to beta times V0. What is this beta? Output voltage Vf divided by input voltage V0. Beta equal to Vf by V0. Beta is feedback factor. But if at all we want Vf over here, it is beta times V naught. So beta times V naught is substituted in place of Vf here. So what is that we are going to have? No change in this term. It is as it is written as AV in minus A times beta V naught. Vf is substituted with beta V naught. Now, next equation is take this V naught on one side of equation and let it be on the other side. So we are going to have V naught plus A beta V naught. So if you take V naught common between this, V naught goes out and we are left with 1 plus A beta. And on the other side of the equation, it is A V in. Now from this equation, you take the voltages on one side and A's and betas on another side. So we are going to have V naught divided by V in equal to A divided by 1 plus A beta. So what is that this V naught divided by V in? V naught by V in is nothing but AF. So substitute AF in place of this one. It is AF equal to A divided by 1 plus A beta. So what is that? Just now as I said, the gain with feedback equal to gain without feedback divided by 1 plus 8 beta. That is gain without feedback is reduced by the factor of 1 plus A beta. And in this, if you assume A beta is very greater than 1, then 1 is neglected. You will be left with only A beta. Then you are going to have AF equal to A divided by A plus beta. AF equal to A divided by A beta. If A is A's are getting cancelled, you are left with 1 divided by beta. So what is AF? The gain with feedback is equal to 1 by beta. That is, it is independent of the basic amplifier gain. So this is how it is independent of the earlier gain, means we say that it has become stable. So after feedback, the amplifier becomes more stable. This is one of the advantage for which the negative feedback is considered. And as the gain increases, there is one more parameter that you have studied in op-amp also. We refer it as gain bandwidth product. If gain reduces, bandwidth increases. So the other advantage of negative feedback amplifier is bandwidth of this increases. The stability also increases. Stability increases is said by this derivation. It is 1 divided by beta, means independent of earlier gain. So it is stable. It is not dependent. So this is what you have come to the conclusion with this derivation and this derivation. This derivation says gain reduces by the factor of 1 plus A beta. Okay, gain reduces. But if gain reduces in gain bandwidth product, bandwidth increases. Okay, this is the conclusion. Bandwidth increases is the advantage. One more advantage is it is becoming independent of A. It is just 1 divided by beta. No A is there. Means it becomes stable. No dependency. This is what you have seen with respect to your negative feedback amplifier and its derivation.